Hello! Today we're going to write and deploy an HTTP service on the Unison Cloud. Unison's library for authoring HTTP services is the routes library. In this walkthrough, we're going to create a simple stateless HTTP service together. Here's what we're going to cover. We'll define some service endpoints, use route helper functions for returning responses, turn our routes-based service into something the cloud can deploy, and deploy the service together. Let's get started. We're going to create a new project that will house our service. The service will respond to requests with the current time. In this project, we're going to need two libraries. The first is the routes library itself, and the second is the cloud client. Both of these are using the latest release alias to pull the latest release, but you can also go to share and pull the latest version. The next thing we're going to do is start defining our service endpoint. It's a good idea to have these service prefixed functions handle one endpoint definition at a time. This endpoint is going to respond to the route/time in UTC. You'll notice as I'm defining this function, there are two ability requirements in the signature. The first is the route ability itself, and the second is the remote ability for running on the cloud. The route ability lets us describe what should happen if the service receives an HTTP request. It enables us to do things like describe what a valid path is, extract path parameters, and set response values. The remote ability describes the effect that this computation is going to be run elsewhere, in this case, on the cloud. The first thing we're going to do is create an endpoint definition using the noCapture function from the route library. It's called noCapture because this particular path doesn't have any path parameters that need to be bound as variables. So we're not going to capture anything from the URL in order to handle this particular route. For our business logic, we're just getting the current time in UTC and transforming it into a text value. The remote ability has a number of nice functions for getting values that otherwise require I/O. Remote.time.now is one of them. The last thing we need to do to define the time endpoint is to form an HTTP response. Here's where the routes library really helps us cut down on the boilerplate of writing HTTP services. Rather than writing an instance of the HTTP response data type where we can set things like our content type, status code, and response body as values, we can use the ok.json function to do the bulk of the work for us. This means we can focus on creating the actual JSON value that the service should respond with, and the routes library will do the rest. Our next endpoint is going to be a service endpoint that takes a path parameter. This one is going to respond to the path time/some time zone code and return the time in that particular zone. So the first thing we're going to do is use the route function to set up this endpoint's path. We're hoping to get a path parameter from this URI. And the second argument to this route is actually a URI parser. We're going to use it to grab a value of type text and bind it to the variable zone. This endpoint needs a helper function for the text pattern match. A user could give us any text value, and we want to make sure it's a time zone code. We'll call this getOffset. There are many time zones because time zones are complicated. So we're just going to add a couple. And I'm here in the Pacific time zone, so I'll add that. We're also going to add a fallback, which will return an optional value of none. Here's a pro tip. Could we have added the route ability to the getOffset function and return the bad request there? Technically, yeah. But that would be mixing HTTP service handling logic in with your business logic, and that can get confusing. Instead, we'll handle the optional in the enclosing service function and do the translation from the optional value into the error code there. That's what we're doing back in the service.getTimeZone function. In the pattern match, if we were able to find a valid offset, we return it in our JSON blob, and if no offset was found, we're using the bad request helper function from the routes library to return a 404 to the user. We've written two endpoints. Let's bind them together into a proper service. We'll do this in a function called timeService using the route.run handler. You can think of the ASCII art operator as the logical OR operator for routing. We give our service routes to the route.run function, which runs our service when it sees an HTTP request from a caller and returns the HTTP response from the service. This is what we'll deploy to the cloud next. You made it! Deploying an HTTP service to the cloud is the easy part. In Unison, deploying a service is as simple as a function call. Everything within the cloud.main function can interact with the cloud. Here, we're calling the deploy HTTP function with our service as its argument. When we run this function, it'll ship our HTTP request to response function to the cloud and return a service hash to uniquely identify it. We give our service hash a nice human-readable name in the subsequent lines. When we save the file and enter run deploy in the UCM, we're sending our time service to the cloud, which publishes it for the world to see. Let's see what calling it looks like. The UCM has printed out the URL of the service for us in the console. Back in the regular terminal, I'm going to use the curl command to test these two endpoints out. The first thing I'm going to run is curl with our named service URL. It's the one prefix with time service, and this root URL won't change with subsequent service deployments. We could have also used the service hash URL directly. Remember, just like a Unison function is identified by a hash of its contents, the service hash uniquely identifies the service code that's being deployed. So if you change the code by adding, say, another route, you'll get a different hash to call. And if you deploy the same code, you'll get the same hash. When we call this, we're not going to forget that we've added a path called time in our first route. And this route has no subsequent arguments, so it should return our time in UTC. I'm going to call this service again, but this time I'll give it a time zone path parameter. Let's try PST. And here we got the time in PST. Well, there you have it. We've written and deployed a service on the cloud. We've used the routes library to describe our endpoints, bound them together in a service, and used the cloud to publish it. We hope you'll have fun writing and deploying your own services on the cloud.